Welcome to a tour of a scale model of a utility scale battery energy storage plant. If we take a look here, we've got a 50 megawatt, 200 megawatt hour utility scale plant. It's comprised of several different components, and we're going to walk through them one by one. If we take a look at this side of the site, we've got all of our energy storage containers. You'll see that there's several containers arranged in a repeating unit. The repeating unit is known as an AC block. If we take a look at this AC block, it's made up of 4 energy storage containers. And in this case, each of these has 5 megawatt hours of energy storage. If it is a 4-hour system, which this one is, that means that each of these blocks is able to output 5 megawatts for 4 hours, giving us a full storage for each AC block of 20 megawatt hours. In the center, between each of these 4, we have a single skid that has both a PCS, or bidirectional inverter, along with a medium voltage transformer. Typical voltages for a system like this would be 1,000 to 1,500 volts DC on the battery side, somewhere between 400 and 800 volts AC coming out of the inverter, and usually somewhere between 20 and 30 kilovolts on the medium voltage transformer. The range on the DC side is because at 1,000 volts, that would be when the system is closest to 0% state of charge, fully discharged, up to close to 1,500 volts when it's fully charged. You'll see here in this system as a whole, we have 5 repeating AC blocks on this row and another 5 on this row, meaning that we have a total of 100 megawatt hours on this side, and this one makes it 200 megawatt hours for the entire system. It's common to arrange the AC blocks in a row like this so that the underground conduit that connects each of the medium voltage transformers can run in a row to connect one to the other, to the other, to the other.